everyone. I hope all of you are doing great. This is Ramiz Zaman. मैंने देखा कि आईआईटी कानपुर ने कुछ सैम्पल पेपर्स अपलोड किया है, मतलब कुछ नहीं, एक ही सैम्पल पेपर अपलोड किया है. उनमें से कुछ क्वेश्चन में से एक क्वेश्चन ये था, लैडर प्रॉब्लम, सॉरी रेलिंग प्रॉब्लम जेई एडवांस के लिए बहुत ही इंपॉर्टेंट है. तो चलिए ये वाला क्वेश्चन हम लोग सॉल्व करते हैं. और बहुत लोगों ने मुझे रिक्वेस्ट भी किया है कि इसको सॉल्व करने के लिए. तो क्या है यहाँ पे, सो दैट देयर इज अ चार्ज्ड कैपेसिटर विच हैज़ बीन चार्ज्ड टू अ पोटेंशियल और वोल्टेज वी नॉट. ओके, at t equals to 0 the key is closed. Neglect friction and self-inductance. There is a rod, okay, of length d, or the railing distance between the railing is d. Mass of the rod is m, resistance is r. Placed perpendicularly on the rails. There is a magnetic field going into the plane of paper. Now which of the options is or are correct? So q as a function of t चाहिए मुझे. t equals to 0 में q equals to c v naught. That is obvious because जब हम लोग ने स्टार्ट किया है, की को स्विच ऑन किया है, t equals to 0 में मैक्सिमम चार्ज रहेगा, that is c into v naught. Okay, so first second option is correct. इसके लिए मुझे कोई चेक करने की ज़रूरत नहीं है. फर्स्ट ऑप्शन भी हम लोग देख सकते हैं. एज यू कैन सी that q equals to v naught by r e to the power minus t by rc. This is the charge decay of charge formula for an RC circuit. बट यहाँ पे अगर हम एनी टाइम t का डायग्राम ड्रॉ करते हैं, सो वी कैन सी दैट ड्यू टू द फ्लो ऑफ करंट देयर विल बी अ मैग्नेटिक फोर्स ऑन द रॉड इंक्रीजिंग इट्स वेलोसिटी, एंड ड्यू टू द प्रेजेंस ऑफ दिस मैग्नेटिक फील्ड B, दिस रॉड विल generate an induced EMF and the equivalent circuit will look something like this. So as you can see that along with this capacitor and the resistance there is also a battery, means induced EMF, which is equal to BVL. So of course this is not a simple RC decay of charge. So first option is wrong. First option will be wrong. Okay, so A is wrong, B is correct. Now we need to check for C and D. Okay, so let's see. So as you can see, at any time t the equivalent circuit will be this. So at any time t the charge of the capacitor is Q, so this is minus Q. I is the current flowing through the circuit, R is the resistance, BVL is the induced EMF. Of course you can check as the rod is moving towards right, so the induced EMF will have this kind of orientation. Fine. So at any time t, the using KVL, that is Kirchhoff's voltage law, we can write that Q by C minus IR minus BVL is equal to 0. Now as the charge is decaying with time, so we can say that I equals to negative dq dt, and also there's a force that is being applied on this rod which is equal to IBL, and that force is responsible for increasing the velocity of the rod. So we can say that MA equals to IBL or M dV dt equals to IBL. Now if we differentiate the first equation, okay, first of all I'm just writing down I as a function of Q and V. Now I'm differentiating this equation. So di dt equals to 1 by R 1 by C dq dt minus BL dV dt. Now dq dt should be negative I. So from here we get a differential equation of di and dt, right? Now we solve it further using integration. So di by I minus this constant limit 0 to t. So at t equals to 0, see, at t equals to 0 the capacitor is fully charged and V naught potential plus minus. Okay, so there is a resistance and there is no velocity of the rod, right? Initially there is no velocity of the rod, so a maximum current of V naught by R will flow through the circuit. So at t equals to 0 current is V naught by R, at any time t the current is I. Now integrating it further, and if you put the lower and upper limits you will get the expression for I, something like this. Now if you find out for Q, of course you will again see that the first option will not match. Now I'm just taking the brackets part here, I'm not taking the whole constant. So M dV dt is equal to I B times L. So M dV equals to BL V naught by R e to the power minus the constant times t to dt. Now the final velocity of the rod will be gained after an infinite time, right? So if I do the integration further, there will be a minus sign here outside the integration. Now putting the limits of 0 to infinity and just rearrange the variables, you will get the final velocity as B V naught LC by M plus B square L square C. So that means I guess option C will be correct. Option C will be correct. Okay, I have taken L as the length of the rod, and here in the answer it is D. Okay, so I guess that won't be a problem. B V0 DC, it should be the answer. Yeah, fine. So option C is correct, hence option D will be wrong. I guess you like the video. Like, subscribe, and I'll see you in the next one. Peace, take care.